let's understand area of rectangles. I know a lot of times we know how to find the area of a rectangle. So if we think about a rectangle, right, a four-sided figure with four right angles where opposite sides are congruent. That's great. And the area is found by taking length times width, where the length is one side of the rectangle and the width is the other. All of this is great. So what we're going to do is really understand how the sides and how when the sides change, it changes the area. So first, let's go to find the area of this basic rectangle. So we know, right, length is 2, width is 1, area is length times width. Okay, so 2 times 1 means the area here is 2 square inches. No problem there. We know how to do that. We're going to use this as our base model. So what happens to the area of a rectangle if the sides of the rectangle are doubled? Okay, so our initial was a 2 by 1. So if I double that, that means I would now have a 4 inches and a 2 inches, right? Instead of a 2 by 1, I have a 4 by 2. And how does that change the area? Well, area is length times width. So 4 times 2, this area is 8 square inches. So when I have a 2 by 1, my area is 2. When I double it and have a 4 by 2, my area is 8. Okay, what happens if the sides are tripled? So instead of a 2 by 1, well, 2 by 1, let's triple both sides, so multiply each side by 3. Now I have a 6 by 3. Okay, well, area, again, length times width. So 6 times 3, my area is 18. Okay, now think this through. We have our basic rectangle, which in this case was a 2 by 1, and the area was 2. When I doubled the sides, so I multiplied the sides by 2, my area became 8, right? So this is where we're talking about the area, which means my area became 4 times, right? Because 2 times 4 gave me 8. So when I doubled the sides, the area was a times 4. When I tripled the sides, right? So when I took the sides and I multiplied by 3, I got an area of 18. Look at that compared to the original. 9 times the original. Now I want to put this into like thought process. Remember that when we talk about area, we talk about square units. And when I double things or I multiply by 2, what's 2 squared? 4. When I triple things, I multiply by 3. Well, what's 3 squared? 9. Is that a coincidence? No, there are no coincidences. This is how things work, right? So if I would continue on and say, well, what if I quadrupled the sides? Which means I don't know what that was. That means I would multiply by 4. Well, what's 4 squared? 16. That means our area would be 16 times. Well, what's 2 times 16? I say the area would be 32. So that means if I had a triangle, or excuse me, a rectangle, our original was 2 by 1. Quadruple means multiply by 4. So at 8 by 4, well, what's 8 times 4? 32. So it checks out. This works with all areas of rectangles, right? As you take a multiple of the sides, it is related by squaring that to find the initial. Isn't that interesting? So just kind of something to put it all in perspective of how areas of rectangles, how the lengths of the sides and the areas are related. And this would work with anything that we used as our base, right? So if I had a rectangle that was, let's just say 8 by 3. So let's call it inches. So 8 times 3 would be 24 inches. If this was our basic, and I said, okay, if we doubled these, remember doubling means times 2, that means our area would be times 4. So the area of that would be 96 square inches. Let's check it just for fun real quick. If I double these, that's 16, and that's, no, that is not 9. 3 times 2 is 6. Well, what's 16 times 6, right? What length times width? 36, 96. There it is. So it works no matter what our base rectangle is. Just something fun thinking about area of rectangles.